Hi everyone. Today we're using the same scenario that we started with last class, but we want to know, can we predict the amount of time you spend on social media based on the number of accounts you have? So first thing we want you guys to do is pause this video and work through 1 through 9, the whole, or 1 through, 9, the whole worksheet. And then you'll come back to this and unpause, and then we'll go over some of the answers. If you're already in class, you can go ahead and continue watching for the debrief and the answers. Okay, so if you were able to go into class, then, do this in class or on your own, either way, you went to stepwell.com and made a scatter plot. We did this last class with this exact same data. And this time you clicked calculate least squares regression line. And so that is right here. The general form of a least squares regression line is y hat equals a plus bx. And remember, x is our explanatory, y is our response. The hat stands for the word predicted, because this is a model that we're using to predict the amount of time someone spends on social media based on their accounts. It's not a guarantee, because this is our real x and this is our real y in this chart, and then we have to differentiate between when we predict and when we have the actual value. And so that's why the hat is there. And then the a is your y-intercept, and the b is your slope. So it's just the equation of a line. When you guys learned this in your algebra class back in the day, you learned y equals mx plus b, and this is the same thing. We just put we put the b in place of the m and the a in place of the b. It makes more sense this way since the y-intercept is like your starting point. Okay, and then don't worry about these other two things yet. We'll learn those later. So here is the least squares regression line. We simplify this by saying LSRL, and this is the line that minimizes the sum of the squares of the vertical distances of the values of the line. What you learned it as back in the day was the line of best fit. It still is. It fits the best because of this definition, because it minimizes, and these are the vertical distances right here. And so this line is the one that makes these squared distances the smallest. Okay, so number 2, we use the regression line to predict the number of minutes spent on social media for someone with 5 accounts. Show work. You always got to show work, including the hat. It's so key. Number 3, and then we always want units, by the way. I'm going to just keep adding that kind of stuff. Number 3, according to the data, someone with 5 accounts spent 100 minutes on social media. So this is going to be what we call our actual or our observed value. And so what was the prediction? Too high or too low, and how far off was it? And so this is called a residual. A residual is your actual y minus your predicted y. And then if we want to write that, we can just write y minus y hat, since we use the hat to show predicted. And then to interpret it, you need to just say how far it was, whether it was too high or too low. Number 4, predict the number for someone with 15 social media accounts. Would you trust this prediction? So 15 is very far outside our range of data provided. Our provided x values were from 0 to 7. 15 is greater than 7 by a lot, and so this is called extrapolation. Which is very unreliable. It's when you predict outside the range of provided x values. And it's what people do all the time to try to predict the future, and it doesn't always work. That's why it's unreliable. And we can try to use our models. There's a famous quote about statistics that says, all models are wrong, but some are useful. And so nothing will be able to get it exactly right, especially when we're predicting in the future. And so the further out you go, the less reliable it is. All right, moving on. The y-intercept, what does this mean? And so we want you to think about some interpretations. And so we're going to ask you to interpret y-intercept and slope. And so for the y-intercept, that's your a value. And we're going to say when x equals 0, the predicted y value is the y-intercept. And so you need to put that in context always. And then for our slope, which is b, this is the slope of a line. And so this is for each additional x. We predict the y value to, and then it's going to be increased or decreased by the slope, depending on the sign of the slope. And you want to use units, and it's got to be in context. Always. And these are just regular interpretations that you've learned from previous math classes, but the main idea is that you have to make sure you use the word predicted when necessary. These are not guarantees, they're just predictions. All right, number 7, we wanted you to just do some playing around with the values and notice some things. First, when you plug in the mean, x bar, you get the mean of the y values, y bar, which means that all least squares regression lines pass through x bar, y bar. And we can also write an equation for the y-intercept for that. So if we know that y bar equals a plus b times x bar, we can solve for the a and say a equals y bar minus b times x bar. So I'm going to highlight that formula. And then this one, we were just trying to show you a formula that works to find the slope. The slope is equal to the correlation times the standard deviation of y over the standard deviation of x. Think about this like slope is y over x, so it works that way that we have the y over the x. Now these are just only used, so I'm going to just highlight this and say only use these when given x bar, y bar, or sy and sx. So you don't have to use those all the time. It's only when you're provided with those values. I just wanted to show you how the formulas work before you saw them. All right, so that was the lesson so far, and I would like for you guys to go to the next page and look at your blank important ideas box, and then pause this video. I'll zoom out for you so you can write these things down. Make sure you got it all in there, sorry. Okay, pause here, and then you can write all of this stuff down. Okay, a couple of things after hopefully you've paused and done that. Remember the hat. The hat is very important. If we were in school, I would be wearing a hat with a Y on it. And you guys would like it, but we're not in school. Maybe I'll wear it on the Zoom call one time. Couple other things. These are variables. Y and X are variables, and A and B are constants. That means that they stay the same in the equation once we plug them in and the x and y change. We have the word, oh, I put extrapolation on there twice. Let's see, I can, hopefully you noticed that and you can take that out. Let's see, we'll just cross this one off. Forgot I'd already added it. Just do this. Okay, there you go. So my first definition is probably better. Hopefully you didn't write it down twice. All right, residual is this formula, observed or actual, same thing. I'll go back and forth with those. And then least squares regression line. Sum of the squares are the residuals. I put the definition as vertical distances. That's what a residual is, because it's the difference from the observed minus the predicted, and so that's the vertical distance. And then we use these formulas when we have the summary statistics. All right, pause here again, and now try to check your understanding. When you're finished and ready to check your work and correct any mistakes, then unpause and come back. All right, here we are. So check your understanding. A, for each additional week after birth, we gotta have the word predict, the weight of the rat to increase by 40 grams. I chose increase because it was positive. The y-intercept, when the rat is 0 weeks old, we predict his weight or her weight to be 100 grams. This makes sense. It's predicting the weight at birth. So again, I have the word predict in there, so necessary, but not all y-intercepts make sense. So you have to check if they do. Sometimes we'll do problems and the x value will be the height of someone and the y will be their weight. So if the height is 0, that doesn't make sense to use that number for the x value. And so we have a y-intercept that doesn't make sense in context. So make sure you pay attention to that. Always show your work. And then here and here, always show work. And your interpretation for your residual should include whether it's too high or too low. And then again, we have extrapolation here with letter E. So we'll take a look at that. You can pause this to check it out and make sure you got them all in case I went too fast. And that is it for today. So hopefully some of this was pretty familiar from your previous math classes, but we do it in a little bit different order. And then we have very specific things we want you to say for interpreting. We will include an interpretations flashcards in Canvas that you guys are able to download and make a Quizlet out of, or physical flashcards to study, because those are things that you're going to have to memorize in order to be able to interpret properly. And we have these flashcards to help out. All right, I hope you guys have a great day, and we will see you soon.